But let me just say good afternoon, everyone. My name is Glenn Shoemate with the ACE Mentor Program of Cleveland and Construction Employers Association. We're glad that you students can join us today. We have what we feel will be a great opportunity for you to learn more about the construction design industry. We have several individuals today who will walk us through a presentation about designing construction in healthcare environments. And I want to initially, I think, turn this over to Jeff Loyal from Turner to start us and kick it off and maybe introduce the team.
You got it. Well, thank you very much. And we're pleased to be here. My name is Jeff Loyal. I am with Turner Construction Company. With me is Russ Sagi, and Russ is an owner's rep with the Cleveland Clinic. And also with us is Brandon Makita, who is a BIM manager for us at Turner. All three of us work together on the health education campus. You'll see a exterior view right now of that on your screen. As we go through our project, we want to let you know what it's like to be in the architectural and construction environment. And we're going to utilize the construction of this project specifically from a quality perspective, and then a very thoughtful perspective of having room for expansion, but also making sure in your design that there was some flexibility for other things that you maybe have not thought was going to be in the building. So our whole role here is to get you acquainted with what it's like being in the architectural construction industry. But the most important thing is we want you to get something out of it. So at any time, if you have any questions whatsoever, please feel free to stop us. If in fact you want to wait till the end of the presentation, we can do that as well. Okay, so, but we're very, very interested in what you may have to say and or any questions that you have. So very quickly, my training and education, I went to Ohio State. I graduated a long time ago in 1986. I got a Bachelor of Science in Civil Engineering. My current role is that of a project executive, which means I have a responsibility to my team, but I also have a responsibility to my client to make sure that we hold up our end of the bargain and give them a phenomenal construction experience. My career path, I started with Turner as a field engineer about 35 years ago. I've worked my way up into a superintendent. I was a project manager. I spent some time in estimating. I was an operations manager. I became a project exec and an officer of the company. And I spent 28 years of that in Chicago. Always wanted to get back to Ohio, and the opportunity to be part of the team to build the health education campus is what brought me back to Ohio. My family and I have since moved back to Ohio, and this is exactly where we want to be. As far as how to get into my field, in high school, health or sciences and mathematics were something that I really, really enjoyed. And, I would highly recommend that if you really want to get into the field and you are able to get into college, you want to get a co-op program for any architect or construction manager. They're all out there, and that really gives you some insights into what the field is like and get your foot in the door. So that's me. I'll have Russ Sagi go next and tell you a little bit about himself.
Hi, good afternoon. Again, I'm Russ Sagi. I work for the Cleveland Clinic. I'm a construction project manager. My training and education, I've got degrees in mechanical engineering and then a degree in healthcare administration. My current role is project manager. I've been doing that with the Cleveland Clinic for just about 20 years. My career path, I started out as a field project engineer for a mechanical contractor in Cleveland and moved on to chief engineer at a local hospital. I eventually worked my way up to a facilities director at that hospital, and then transferred to the Cleveland Clinic as a project manager, like I said, 20 years ago. So I've held 3 jobs in my life, basically. How to get into my field, as Jeff mentioned, co-ops. We also, on larger projects, we require and encourage interns and internships. And there's two ways to do that. One is through the project itself, where somebody like Turner or the other contract manager would, construction manager, would take on an intern for a duration of time and be a paid position. Then there's also opportunities with the Cleveland Clinic itself to do a summer intern. We have a 6-week program that we do every year, and there's availability to do that. And finally, we promote induction into the trade pre-apprenticeship program. If you want to become a carpenter, electrician, or whatnot, we can promote you getting started into the trades themselves. So I'll turn it over to Brandon Makita now, who can introduce himself.
Yes, so my name is Brandon Makita. I am a BIM manager and MEP project engineer for Turner Construction. I went to undergrad and graduate school at Kent State University for architecture. My current role right now, as Jeff had mentioned, I am a BIM manager and then as well as an MEP project engineer. I started right out of graduate school working for 2 architecture firms, one in Phoenix and then one in Cleveland. And for the firm in Cleveland, I participated a lot in punch list and construction administration work. And that's when I noticed that I preferred being on site more and enjoyed the construction aspect. And that is when I made the transition after a few years being in the architecture field to work for Turner. Started off as a field engineer and went to focusing on the BIM management and project engineer role as of now, and I've been with Turner for 5 years. How to get into my field, I guess I think Russ and Jeff both did hit on really good points, which some of my stuff would be kind of reiterating that, but math and science were always my strong points, and having the design, the love for design as well, which is what got me into architecture. I also took certain classes in CAD at my high school that they offered, and additional programs that were done outside of my high school or that were incorporated with my high school. And then other options as well, if you're even interested in construction, is also doing a trade school as well.
Great, thanks, Brandon. So on the next slide, this will show you the interior of the health education campus. To give you an idea as to how big this is, in the courtyard, you could probably fit a football field in there. And quite frankly, you probably could also punt that football because the trusses that you see on the top, they're about 65 feet up there in the air. The health education campus is the new home for 4 schools. It's the Lerner College of Medicine by the Cleveland Clinic. And then the Case Western Reserve University has their School of Medicine, School of Dentistry, and their Francis Payne Bolton School of Nursing. So there's 4 schools in here. Another thing to give you the sense of scale, you can see that it's 4 stories high, and you can see the walkways of all 3 of the elevated floors. On the very, very top floor, 1 lap around that is 1/4 of a mile. So you can see, you can really put together a pretty good workout utilizing those stairs that you see here that seem to be floating in that atrium itself. And one of the things, again, to give you the size, all the concrete in here, if it was a typical sidewalk and you filled it with all the concrete that was in here, that would be about 75 miles long of a sidewalk. So it's a pretty big building. Next, we'll have Russ walk you through a little bit more detailed look of each one of the floors and the programs that exist there.
All right, so if we go to the next slide, it's the floor plan of the first floor. And as you can see, the courtyard, there's a cafeteria. There are 2, or 1 large tiered lecture hall. It's got a tremendous video screen. I think there will be a shot of that coming up. There's several what they call team-based learning classrooms. This is where the students get their instructions from the instructor, and they go off in their teams to do problem solving. There's also the dental preclinical lab where dental students practice on dummy heads to fill teeth and that type of thing. So the next slide will show us the second floor. I'm sorry. On the first floor, we also have the flight simulation lab. That's a fuselage of a helicopter that is parked next to an ambulance, and the flight academy students can practice treating patients in the air, so to speak, and then practice transporting patients from the ambulance to the helicopter to the intensive care classrooms on the upper floors. The only one of its kind in the country. And the next slide would be the second floor now. Library and the simulation center. The schools have all simulated anatomy. There is no cadaveric anatomy in this building. The cadaveric anatomy occurs back at the Case main campus. That allowed us to simplify the infrastructure, the air conditioning requirements in the building, because not having to deal with cadavers and formaldehyde and that type of thing. And then all the rooms around the perimeter, you can see are the problem-based learning rooms. That's where the students go and work as a group to solve the problem that their instructor gave them. And then we've got two very large dental medicine classrooms on the east and west side. And go to the next slide. And this is one of the patient simulation rooms where the students work on mannequins. And the mannequins actually are programmed to do things like they have respiration and pulse and that type of thing. So the students get a very realistic experience of what it's like to work on or perform operations of that type on a mannequin patient. Next slide would be this is the simulating a crash, a patient in medical distress, where the team comes together and provides medical care in a very realistic situation. And then we go to the next slide. This actually is the third floor, and we were able to move the dental clinical practice out of this building and into its own separate building across Chester. And that freed up basically the entire third floor, which is room for expansion, which is a great thing to have. It's a luxury when you're doing buildings, actually. And the next slide is the fourth floor. And this is all the administration spaces for the various schools, as well as the student learning centers where students can gather and collaborate, kick back, study, whatever they want. It's an open, flexible space. And with that, I'll turn it over to Jeff, who will discuss the features of the building.
Great, thanks, Russ. So this is an architectural rendering of the building before we even broke ground. And what we're going to show you next is a view, a very similar view from the Cryo building where we mounted a time-lapse camera. And so Brandon is going to initiate that time-lapse camera, and you're going to see about 39% of construction. And I'm sorry, 39 months. Now, each second represents about 1 month. And almost every construction project has a time-lapse camera in order to document the progress of the construction that you're utilizing. And at any given time on an iPad or an iPhone, we could go ahead and take a look at what the construction was at any given month. One of the beauties you can see here is that the acreage was about 13 acres. The building occupied half of that. So the construction trades always had ample parking on site, which is a rarity. In addition to that, we had our trailers that were also able to be on site. And so with that, we did an awful lot of innovative uses of technology. in order to manage and control the project. Now, on the next slide, we're going to show you a view of what we call co-location. Now, traditionally, the way it has always been is that the construction manager had their own trailer. The architect would usually be in their offices, and then the owner would either be in their separate trailer or in their offices. Well, co-location is when you bring all the disciplines together for the value of the job. And traditionally, there were an awful lot of inefficiencies in the way that we prosecuted work. Co-location is to get rid of any waste so that therefore, if you had issues, you tackle those issues right away. And so this is a view of my cubicle right across the table that you see there is Russ Sagi, who's talking with you today. And then right behind him is one of our co-ops. That co-op is now a Turner Construction employee. That individual had a full ride to Case Western Reserve University to become a civil engineer. That wooden table that you see that we all shared, that was incredibly valuable because that was an area that we were able to solve an awful lot of problems and agree on what the cost of the project would be after we've already started construction. Now, granted, with that setup, you all have areas where you have to have some confidential conversations. So the small room to your right was just that. It was a confidential room that if you had to have a phone call from an HR perspective or what have you, you were able to do that with your human relations people. Now, the advent of COVID, you'll see most of these people, or none of them have masks. That's going to be interesting. And we're all going to have to get together and figure out how do we still co-locate during COVID, but yet still have the value of the project. That'll be the next chapter that we're all trying to figure out. On the next slide, you'll see you have an awful lot of innovative uses of technology. So you can see someone there holding an iPad. All the drawings that we have for the project were all on an iPad. You could access from a DOS type computer or even any kind of smartphone. But that's where we were able to take the drawings out to the field and electronically be able to see what really, if you will, what work in place went in next. We also did our safety checks on with uses of technology as well. On the next slide is an example of one of the quality reports that we would do. And we would do these audits. Everybody had an assignment where once a month, they had to go out onto the field, not only do a quality audit, but they also had to do a safety audit as well. On the next slide, you can see where you see on the left side, the rendering of the building. On the right side were all the structural steel that was required for that building. The areas that were in green were the areas that were approved by the structural engineer and the fabricator of the steel through a shop drawing perspective, but we did that all electronically. The areas that you see in blue were the areas that had yet to be drawn and it had yet to be approved. So essentially what you wanted was the fabricator on the same page as the structural engineer before any steel was made in the shop and sent out to the field for installation. And then you see the area that's highlighted in red. That was the area that was on hold pending redesign. So essentially, by utilizing technology for this, on the next slide, we'll show you where our team was able to save about $230,000, and that money went back to the client because we were able to reduce the time it took for the paper drawings to go back and forth. We were able to accelerate the reviews by 24 weeks, and all that amounted to about $230,000 of savings. This is value added. This is also one of the lean concepts called continuous improvement. And we had many examples of this throughout the life of the project. All right, next, I'll turn it over to Russ, and he's going to talk to you a little bit about metrology.
So this building had never been built before. It's a one-off design, and there are a lot of challenges, and one of them were what they call a spandrel truss, which is that big unit that the gentleman is measuring, and what he's using to measure it is a laser metrology device that measures the location in space over any surface, and he runs this stylus across the surface, and he's checking for the end result. If you go back or go to the next slide, you'll see they checked the steel structure and came up with the amount of shimming that was required to make everything perfectly level, perfectly flat. And believe it or not, they got it to within 1/16 of an inch over the 30-foot span, which is incredible. It's an unheard of construction tolerance, but we needed that in order to have the building look right. So if you go to the next slide, another innovation was the steel trusses that you saw in the time lapse going up onto the building. They were constructed in Kansas City, Missouri, full length, all 150 feet long, and then cut into 3 pieces and transported overland by truck and brought to the site. And the steel erectors had to figure out how to pick them up, turn them over because they're laying upside down in the parking lot, and get them into place in a safe manner. And the way they did that was to build this model that the project manager is holding. And with his team of workers, they figured out how to strap it, how to rig it, how to lift it safely, and not lifting over anybody's head. Safety is the number 1 priority, and quality is number 2 priority. And so going on to the next slide, this project sourced material from all over the world, Europe, Australia, all over the continental United States. And we're very proactive with quality, as I mentioned. And believe it or not, I went to about 14 of these locations, 7 of them out of the country, to visit the fabrication shop, to see what they're doing and make sure that what they were doing met our standards, and they didn't ship anything that was going to be rejected. So on the next slide, I'll let Jeff talk about more quality control.
Thanks, Russ. So one of the things that we like to do is have a series of mock-ups. And what you want to do, you want to have definable features that are in your design that you want to, if you will, mock up, whether it's going to be an in-place mock-up like a drywall wall, or if you want an on-site mock-up like what you see here, which are certain features that will go into the building, or a performance mock-up that Russ is going to get to in a moment. But the beauty of having a mock-up is you have a compare to, from a quality perspective. You have your workers, your designers, and your engineers get together, and they mock up. You can see in the upper left-hand corner a stair. In the middle photo, you see a portion of the trusses. On the right, you see the glass, and that's going to be on the outside of the building. And so what you want to do is you want to mock those up almost to a point of failure. So you make the mistakes on the mock-up and you learn from those mistakes, and you have a playbook. So by the time you go and actually build that on the permanent building, you have a lot of quality and you don't have any mistakes or any damage. One specific example was the trusses that you see in the middle. There were a lot of welds in order to put that structural steel together. The architect at one time had envisioned grinding out all the welds. So the welds are what connects the steel. And you see a piece of, if you will, putty. It's actually molten metal that actually hardens and is actually stronger than the actual steel itself. Well, the architect wanted it ground. Unground would have been a savings of $600,000. So we had the CEO of the Cleveland Clinic and the president of Case Western on the mock-up one day. And we asked them, would you like to save $600,000? If so, keep the welds where they are. And they all agreed, yes, that's what we want to do. So in the lower left-hand corner, we mocked up every field weld that would happen on those exterior trusses just so there was an expectation as to what was expected. And so if any time, anywhere, any of those trusses came to the site and someone had an issue with one of the welds, they were to go back to this collage of welds, if you will, see what the agreed upon feature was, and that would be your compare to. And one of the beauties is every piece of truss that came on out that went up onto the structure, not one was ever rejected. So it was a success. On the next slide, Russ is going to walk you through that quality program that we utilize for all the definable features.
So this is the fabrication shop in Kansas City, Missouri. And the second picture from the left is our quality control team, which is the structural engineer, the architect, me, and the Turner quality control person reviewing the truss and reviewing the welds. And actually they had a weld tree at the fab shop as well. So the welders could walk over to the weld tree and see exactly what level of quality was expected of them. So as Jeff said, not one truss was rejected on site. Everything they sent to us went up in the air eventually. So we think that's a huge success story. And the next slide is a mock-up of the exterior facade, the curtain wall. Again, we're building something that was never built before, so you do a lot of extensive testing to make sure it's going to stand up to the weather and to wind conditions. And actually, this mock-up survived a hurricane in Fort Lauderdale. That's the only facility in the country big enough to be able to do a mock-up of this size. And on the left-hand corner, left-hand picture, you can see they are water testing it. They spray water on it, and they use that airplane engine to blow 70-mile-an-hour wind on it to try and force water through the glass joints. And they found a couple of things that they had to improve on. And through the testing, they knew what they had to watch out for in the field. So knock on wood, we've had no leaks in the building since they put it up.
Yeah, exactly.
And next we'll go to Brandon. He's going to explain the use of BIM.
Great, thank you, Russ. So continuing discussions on quality that Jeff and Russ had previously mentioned, I'm going to go into some detail in regards to unique MEP features within the building, as well as BIM, which is Building Information Modeling, and prefabrication. So BIM and prefabrication work hand in hand and are key factors to handing over a quality building to the owner. From a quality perspective, the largest benefit of BIM is being able to work through clashes before material shows up on site through your model. Years ago, clashes sometimes were not discovered until install was occurring out on site, which would cause slower install times, increased labor costs, and sometimes wasted material. You know, working these clashes out in our 3D model ahead of time through the BIM process helps with the quality of the end product, the safety of the workers, limiting wasted material, and efficiency of the install. I'll go into more detail of examples of prefabrication in the shop environment of our subcontractors as well. So this image here, one of the unique items was the blue duct, which is the underground ductwork within the atrium space. And this pre-insulated ductwork takes approximately half the time to install than standard PVC or fiberglass. It's rust resistant and mold and mildew resistant and recyclable. One of our MEP superintendents actually recommended this product to the design team due to the long-term product benefits. And here you could see an additional image kind of scaled out from one of the walkways. You could see they're backfilling in the ductwork and the gravel, prepping it to get all the insulation as well as the granite floor that would go over top. Another unique feature here shown is the radiant heating and cooling within the atrium space and all the surrounding walkways that Jeff has spoken about. There's 8.5 miles of tubing in this building, and this system functions as supplemental heating and cooling within that large atrium space. And the heating and cooling tubing can give more control over temperatures within the space, as large spaces are hard to get even temperatures. For example, the air handler may be set to 75 degrees, but the radiant floor cooling function can assist in fine tuning that temperature to a more finite 72.5 degrees, and it's directly where a visitor is walking. This also helps with, this also can be used in a way to reduce utility bills. And the next photo here, the next two photos here is on the left-hand side, it shows prefabricated pipe for the north penthouse that were spooled and created off of our BIM coordination model. So what happens is the detailers from their 3D model spit this to a machine that will actually fabricate this material and cut it exactly as the model shows, and all products will come out labeled individually. It's coded with an item number for the field assembly and installation. In a few more slides, I'll show an example of a ductwork install drawing that the field staff use, and can explain that more in depth as well. The image on the right is another example of prefabricated pipe of branch lines of the piping that connected to the chilled beams within the building. The next slide.
Hey, Brandon, I think we actually have a question out there. Chris, okay. There might be a question out there.
And good afternoon again, Jeff and Russ and Brandon. Chris Nance with the Greater Cleveland Partnership, and I work with Turner and the Cleveland Clinic and connecting women and young people and minorities to the construction sector. And I've been really just overwhelmed. I also happen to live across the street from the health education campus. So watching this amazing building go up was really extraordinary, especially seeing the time lapse. When I think about the young people, CMSD, who are looking at careers in construction, I heard a couple of references to internships that on the kind of the management or professional side of the work. I also heard you talk about co-ops. I also heard you talk about pre-apprenticeships and apprenticeship opportunities. So could you say a little bit more about for young people who are looking at kind of that starting point, right, that bridge from, no pun intended, from where they are today, you know, to the work that you're describing? What are a couple of things that kind of specific roles that you could share a little more detail on? And if you could also say a little bit about what are you looking for in terms of the quality, in terms of the characteristics of folks that you, young people in particular, that you see have potential to be successful in the construction sector?
Yeah, I'll go ahead and take the first stab at that. Chris, excellent question. What you want to see is, are you a person who likes to work with other people? Communication is everything, and probably 98% of all the problems that happen in design and construction are communication related. And our project team spent so much time and effort into figuring out ways to improve communication for the value of the project. But you really want people that really like to work together as a team. You had described the full spectrum, Chris, of all of the opportunities in construction and design, whether it's working within the trades out in the field or working with the professional staff. We did have apprenticeships that we had in all of our subcontractors were encouraged to have a portion of their payrolls made available for apprenticeships. And, you know, I'll never, ever forget it. We had one young lady who had worked as a labor apprentice. And we actually have a picture of her. She was so happy with her first paycheck. It was absolutely phenomenal. We had another gentleman that you saw that was in the trailer that Russ and I were in. And he was a co-op. And he he accepted a full ride, a full scholarship to Case Western for civil engineering. He got his first taste of what it's like to be in design and construction on our project. as a co-op, and that was absolutely phenomenal. Now, Russ had also talked about some of the internships that they have at the Cleveland Clinic as well. Russ, would you like to talk a little bit more about those?
Sure. Our summer internship program is in conjunction with the CMSD, and we're looking for high school students that, as Jeff mentioned, are outgoing, communicative, and interested in various fields. We have a medical track, we have an administration track. The administration track is the students that I get, and we bring them out into the field and have them help out doing things like Jeff mentioned with safety audits and quality control inspections, that type of thing. So it's a 6-week program that the students can get their feet wet. And if they're interested, we welcome them back for a longer duration based on their availability and their scholastic availability and their scholastic dreams and motivation. So there's lots of opportunities there. We also, like I mentioned, and Jeff mentioned, we encourage the contractors to bring on interns, either for short duration or long duration. And that often turns into full-time employment opportunities, as it did with the gentleman Jeff mentioned. So we're open, just to reach out to us and we'll try and connect in some way.
Yeah.
Does that answer your question?
Yeah. Thank you both. That absolutely. And if you wouldn't mind sharing your contact information in the chat, that way it'll be a part of our ability for students to be able to find how to connect with you. And I know that Brandon also has a few more slides as we are rounding third and heading home. We need to wrap up, but Brandon, I wanted to make sure that you had a chance to share some final thoughts on the slides that you were reviewing relative to MEP. Brandon?
All right, great. So the next slide here that's shown is actually images from our mechanical subcontractors fabrication shop. And the image on the left shows how the material for the fin tube manufacturer shipped to our subcontractor. You could see how many boxes are there stacked and materials are separated within the boxes. The image on the right shows how our mechanical subcontractor put pieces together based on what was modeled through their BIM model. So all these pieces are tagged and noted where in the building they should be installed. So on site, the only thing the mechanical subcontractor would need to do is set the fin tube in this right location and make the connection to these copper pipes. Doing this work in the shop gives our subcontractors a controlled environment to work in with tools more organized and nearby. It gives them more square footage, and it's more safe and efficient install out on site as they know exactly where they're going, and it does help with lower labor costs. These next few slides are fairly quick, but basically in the building information modeling and the BIM model, this is the example of the boiler room. And then over here on the right, you could see the install. You could see how detailed it is, even looking here at this pipe with the valve. Valve is here installed. Basically, this install should be matching what is shown in the model. And that is because everything is being fabricated from there and being properly labeled, as I mentioned. You can see here is the chiller room. Even the steel here was, modeled in and fabricated to make sure it was put in the right place.
Hey, Brandon,
Yes.
why don't we, I think we have probably about 3 minutes left. So why don't we jump to the Surge Hospital, and we'll let Russ talk a little bit about the flexibility of the building, and that'll get us to the 220 timeframe that Chris was talking about.
Yeah, I'd be happy to. As Jeff mentioned, the building was designed with flexibility in mind. And what's more flexible than taking a school and turning it into a 2,000 bed COVID hospital in 2 weeks? On the left is the atrium as a 600 beds in it. There's another 1,400 beds elsewhere in the building. Thankfully, we never got the opportunity to use it. So if you go to the next slide, there's more beds spread out through the building. Go to the next slide, please. So again, being flexible, you probably saw the first presidential debate that was hosted in Cleveland, and this building hosted that debate. And go to the next slide. And you can see where everything for the school was moved out and the stage was set up for the debate candidates to hold the debate. So again, lots of flexibility. It's a great space. You can do just about anything in that space.
So next slide should take us to any questions that anybody has that Russ or Brendan or I could answer.
I think that the overall presentation, I know one of the things that you would encourage if outside of the COVID-19 environment is actually coming and visiting the health education campus. It is an absolutely beautiful building, and it's really incredible to see all of the strategy that went into not only building what is an incredible and unique education space, but how both creative and brilliantly and creatively and beautifully presented this building is. So just in the interest of time, I think we need to bring the session to a close, but I wanted to thank on behalf of Eric Gordon and the Cleveland Municipal School District. We really appreciate you taking the time to invest in the students who are interested in the world of construction, and certainly the expertise that was shared both by the Turner and the Cleveland Clinic teams today is a great example of the kind of expertise from whether you want to work with your hands, whether you're interested in management or professional services. The construction sector has a lot of opportunities, and also we had a chance to learn where young people can get started through co-ops and internships and other summer programs. So again, I'd like to thank you, all of you gentlemen, for participating today. And with that, I will bring this particular session to a close. Thanks again and have a great day.
Thank you, Chris.